Welcome to Edvantedge, the learning network. My name is Raghukumar Chichula and I am taking permutations today. It is permutation, if you refer to the English dictionary, its meaning is arrangements. Arrangements of things or objects is nothing but a permutation. Before entering into the topic, you must know the fundamental theorem on arithmetic. What is this fundamental theorem on arithmetic? Let us see the definition. If an operation, what is an operation? The day-to-day works, what we take, is termed as an operation. So, if an operation can be performed in m different ways independently, and second operation can be performed in n different ways independently, then these two operations can be performed in m into n different ways, one after the other, or simultaneously. To explain this fundamental theorem on arithmetic, let us suppose we are in Hyderabad today and we want to move to Mumbai, and from there we want to move to New York. So, to move from Hyderabad to New York via Mumbai, let us see the means of transport. From Hyderabad to Mumbai, we have the roadway, railway and airway. From Mumbai to New York, let us suppose there is a seaway and airway. So a person wants to travel from Hyderabad to Mumbai and then to New York. There are three ways to go from Hyderabad to Mumbai, and from Mumbai to New York there are two ways to go. In how many ways the person can travel from Hyderabad to New York via Mumbai? Now, let us say he started on the roadway, then he can move to New York in two different ways. Similarly, he started on railway, then he has two different ways to go, that is 2, and he started on the airway, again he has two ways to go to New York, there are 2, and added together it is 2 plus 2 plus 2, which is 6. This 6 is nothing but 3 into 2. So, an operation, first operation can be performed in 3 different ways independently, and the second operation can be performed in 2 different ways independently, and these operations, these 2 operations, one after the other or simultaneously, can be performed in 3 into 2 different ways. That's what the definition is. If an operation can be performed in m different ways independently and second operation can be performed in n different ways independently, these 2 operations can be performed in m into n different ways, one after the other or simultaneously, and it can be extended to any number of operations like that. So, the fundamental theorem now can be extended to any number of operations, like if you take the first operation, which can be performed in m different ways, and the second operation can be performed in n different ways, and the third operation can be performed in p different ways, and so on, then all these operations can be performed in m into n into p into so on different ways. This is called the fundamental theorem on arithmetic. Now, we will now apply this to the mathematics. Let us take 1, 2, 3, 4 are the digits given to us. Now we want to form 2-digit numbers from using these 4 digits. Now, 2-digit numbers, as you all know, contains two places. This is ones place, this is tens place. Now, I want to know how many two-digit numbers that can be formed from these four digits. Now, what I do, I want to fill these blank places with these given digits 1, 2, 3, 4. Now, first blank place can be filled with either 1 or 2 or 3 or 4. So, it can be performed in 4 different ways. This second blank place can be filled with the remaining 3 digits. Why remaining 3 digits? Because first blank place we have filled with either 1 or 2 or 3 or 4. So first blank place is already filled with 1 digit. Only 3 digits are remaining here, and these 3 digits can be filled in the second blank place in 3 different ways. So this is the first operation we performed, that is filling up of the first blank place with any one of these 4 digits in 4 ways, and the second blank place is done in 3 different ways. And these two operations, one after the other or simultaneously, can be performed in 4 into 3 is equal to 12 different ways. Let us think practically without applying this fundamental theorem on arithmetic. Let us see what is this 12 ways. So let me write that. It's common sense, everybody can do that. It is 1, 2 is 1 digit, and again rearrange it. It is 2, 1, because permutations are nothing but the arrangement of things. So that is why I have rearranged it. Next is 1, 3, it is 3, 1. Next is 1, 4, it is 4, 1. Next is 2, 3, it is 3, 2. Next is 2, 4, it is 4, 2. Next is 3, 4, it is 4, 3. You count this, these are totally 12 different arrangements. So you can form two-digit numbers from the given digits 1, 2, 3, 4 or 12. These 12 are shown separately for your better understanding. Now, I think somebody is raising the hand there from one center. Yes, please ask the question, please.
So, since we are doing combinations, why can't we use the same digit which was used in the tens place again in the first place, in the ones place, so that we can make new combinations? Why can't we do that?
Yeah, understood. Okay. So, what the question is, here what is asking, I have taken 3 digits here in the second blank place. Now, his question is, he is saying that why shouldn't we take 4 here? That's a good question, very good question. Right, now let us see what the two-digit numbers I have written. All these are without repetition. I have not mentioned it, just I want to see all of you, how many of you are aware of this fact. Very good, that student asked this question, and what I wrote here is all without repetition. Then I can repeat the digits also. In such a case, in how many ways these operations can be performed. And as you see, the first blank place can be filled in 4 different ways. There is no change in this one, because either 1 or 2 or 3 or 4 can be filled in this one. Similarly, if you take the second blank place, now when the repetition of the things is allowed, can also be filled with 1 or 2 or 3 or 4. In such a case, this operation can also be performed in 4 different ways. Then these two operations, one after the other or simultaneously, can be performed in 4 into 4 is equal to 16 different ways. That's a good question. This is with repetition. So, what are the 4 extra things you are getting here? Because you have got 16 here, you have got 12 only here. What are the 4 extra things here? They are 1, 1, 2, 2, 3, 3, 4, 4. So, in this one, the digits are repeated. Now, if you add this 4 to this 12, you are getting 16. So, these are the number of permutations without repetition, and these are the permutations with repetition.